network in MyNet. Okay, so let us start this. Properties of definite integrals. Properties of definite integrals. These are the basic properties of definite integrals. You know what are definite integrals? After finding the antiderivative of the function, you have to use the limits. This is the lower limit, a is the lower limit, and b is the upper limit here. In the first one, you see you can change the variable. It was integral of fx dx. The lower limit was a, upper limit b. You can change the variable. X can be written as any other variable, say u, say p, t, etc. Here it is written z. You can change the variable. In the number 2, a to b, integral of fx dx. If you change the limits, the position of the limits, upper limit to lower limit and lower limit to upper limit, you have to put a minus sign here. Okay, if you interchange the limits. In number 3, the limit was a to b fx. If c lies in between a and b, if c is a number which is in between a and b, you can write it like this: a to c integral of fx plus c to b integral of fx. So you can separate this integral into two parts. This is a very important property in number 4. 0 to a fx dx, you can write it as limit is not changing. 0 to a, the function can be written as f of a minus x dx. So this is very important. 0 to a fx dx, it is equal to 0 integral 0 to a f of a minus x dx. Now in number 5, 0 to na, where n is a positive integer. N is a positive integer. 0 to na fx dx, it will be n into 0 to a fx dx if f of x equal to f of a plus x. N is a positive integer. You see, this is another important property. 0 to n into a. N is a positive integer. It will be equal to n into integral 0 to a fx dx only when f of x equals to f of a plus x. Now, number 6. Number 6, 0 to 2a fx dx, it will be equal to 0 to a fx dx plus integral 0 to a f of 2a minus x dx. Here, how to get it? You just at first you write this integral in this way: 0 to a fx dx and then integral a to 2a fx dx. Then you use a substitution, x equal to 2a minus z. So when x equal to a, okay, when x equal to 2a, z will be 0, and when x equal to a, z will be equal to a. So the ultimately the limit will be a to 0, but there will be a minus, and because dx will be equal to minus dz. And then if you adjust the minus sign with the limits, ultimately you will get integral 0 to a f of 2a minus z dz. But you can change the variable. You can write x in place of z. So ultimately it will be integral 0 to a f of 2a minus x dx. Okay. Now number 7, integral 0 to 2a fx dx equal to 2 into integral 0 to a fx dx if f of 2a minus x equal to fx. Actually, it is an extension of the previous property number 6. You see, if f of 2a minus x equal to fx, then you can write here 0 to a f of x dx, and ultimately 0 to a fx dx, 0 to a fx dx. So when you add them, it will be 2 into integral 0 to a fx dx. But if f of 2a minus x equal to minus fx, then these two terms will be cancelled. So actually number 7 is an extension of number 6. If f of 2a minus x equal to fx, then you we will get the first expression 2 into integral 0 to a. But if f of 2a minus x equal to minus of fx, then you will get 0. Number 8. Integral minus a to plus a fx dx. This will be equal to 2 into integral 0 to a fx dx if f of minus x, if f of minus x equal to fx. That means if fx is an even function. This is the definition of even function. If you replace x by minus x and if you see that f of minus x equals to fx, then you say, we can say that fx is an even function. So this result will come if fx is an even function, and 0 will come up if fx is an odd function. That means if f of minus x equal to minus of fx. If f of minus x equal to negative of fx, then the result will be 0. That means when fx is an odd function, the result of this integral will be 0. So these are the properties here. These are the properties here. Here number 4, and number 8. Actually number 4, number 5. Yes, number 4, number 5 and number 8. These are very, very important. Using this, this Wallis formula, actually we can get it from the reduction formula of integral sine to the power nx dx. Okay, so if you take in equal to integral 0 to pi by 2 sine to the power nx dx, we have actually got the reduction formula for the indefinite integral of sine to the power nx dx. Here we will do the same thing. At first you check, actually 0 to pi by 2 sine to the power nx dx is equal to 0 to pi by 2 cos to the power nx dx. How? Here the property is used. Which property? It was number 4. Yes, this property. 0 to a fx dx equal to 0 to a f of a minus x dx. So if you use this property number 4 here, you see your 0 is 0 and in place of a you have pi by 2. So according to property number 4, it will be equal to 0 to pi by 2 sine of pi by 2 minus x whole to the power n, and sine of pi by 2 minus x, actually it gives you cos x. So ultimately cos to the power nx. So here we see that this definite integral 0 to pi by 2 sine to the power nx dx equals to 0 to pi by 2 cos to the power nx dx. Now we will find the formula for this definite integral, which we start from sine to the power nx. So you at first you separate two functions. You write sine to the power nx as sine to the power n minus 1x into sine x. Then you apply integration by parts. Take sine x as the first function and sine to the power n minus 1x as the second function. Then use just the method of integration by parts. Here you see in the first term you will have sine to the power n minus 1x into minus cos x. If you use the limits here, you see cos pi by 2 is 0. So for the upper limit, the term becomes 0. And when you put the lower limit, cos 0 is 1, but sine 0 is 0. So the lower limit is also 0. So ultimately, we are left with this thing. Then now you write for this cos square x 1 minus sine square x and then separate the term. The first term will contain the power n minus 2 and the second term under the integral sign, the power of sine will be n. So here you can take this term to the left side. It will be in the left side it was in. Now it becomes in plus n minus 1 into in. So take in common. It will be 1 plus n minus 1. 1 and minus 1 will cancel. You will get n into in equal to this. N minus 1 into integral 0 to pi by 2 sine to the power n minus 2 x dx. So you divide by n and you write this part as in minus 2, n minus 1 into in minus 2, because if in is integral 0 to pi by 2 sine to the power nx dx, if the power is n minus 2, everything is same, the limits are also same, you can denote it by in minus 2. So ultimately the value of in becomes n minus 1 divided by n into in minus 2. Now again use this value for this in minus 2. You see when the value of in For the value of in, you are getting n minus 1 by n into in minus 2. So what will be the value in minus 2? In minus 2 will be equal to, you just put here in place of n, you have to put n minus 2. So ultimately it will be n minus 3, n minus 3, in place of n you have n minus 2, and here it will be less by 2, so it will be n minus 4, in minus 4. Similarly, again, if you use this relation for the index n minus 4, these two factors will be there, n minus 1 into n minus 3 by n minus 2 into, at first in the lower part it will be n minus 4, and in the upper part it will be n minus 5. In this way, you see it will be decreasing like this, n minus 1 in the upper part, n minus 1, then n minus 3, so n is decreasing by 2, n minus 3, n minus 5, and if n is an odd integer, if n is an odd integer, the upper part will be all even numbers. You see, ultimately, in some place, after a certain time, you will get here 4. It will be decreased by 2, so 2. In the lower part, all that numbers will be odd because n is odd. Okay, so when in the upper part it is 4, in the lower part it will be 5, just one greater. You see, n minus 1 by n minus 3 by n minus 2, n minus 5 by n minus 4, and so on. So when it is 4 in the upper part, it will be 5, 4 by 5, then it will be 2 by 3, and here it will be 1 less. You see, n minus 3, then n minus 4. When the upper part is n minus 3, the index of I is n minus 4. So when the upper part is the number 2, the index of I will be 1. Okay, this expression comes when n is an odd integer, but if n is an even integer, even number minus odd number, it will be odd. So sometimes after certain time it will be 5 by 6, 5 by 6, then 3 by 4, 3 minus 2 is 1, so 1 by 2, and 1 minus 1 is 0, so then our index of I would be 0. Then you let us now find the value of I1 and I0. I0 will be integral, the power of sine will be 0, sine to the power 0 is 1. So I0 means integral 0 to pi by 2 dx, which is x with the limit 0 to pi by 2. So the result will be ultimately pi by 2. And what will be the value of I1? You see, integral 0 to pi by 2 sin x. The integration is minus, gives you minus cos x. Then use the limits. Minus cos pi by 2, it is 0. Then minus of minus of minus cos 0, that means 2 minus 1, so plus cos 0 is 1. So here it will, the value of this integration in will be like this. If n is an odd integer, it will be n minus 1 by n into n minus 3 by n minus 2 up to 4 by 5, 2 by 3, then 1. Then 1 if n is an odd integer, but if n is an even integer, these factors will be same, n minus 1 by n, n minus 3 by n minus 2, these factors are same, but at the end you will get odd numbers in the upper part, even numbers in the lower part. So 3 by 4, then 1 by half, 1 by 2, I0 means pi by 2. Okay, this is known as Wallis formula. This is known as Wallis formula. You see, we have already proved that 0 to pi by 2 sine to the power nx dx is exactly same as 0 to pi by 2 cos to the power nx dx, and both the integrals have these values. This the upper one, the first one comes when n is odd, and the lower comes when n is even. So this is known as Wallis formula. We first do a math on this formula. Excuse me for a moment, just a minute. So the first math on Wallis formula. integration 0 to pi by 2 sine square x cos to the power 8x dx. So here, at first we write 1 minus cos square x for this sine square x. So here you are getting two terms, one integral with cos to the power 8x minus the same integration cos to the power 10x. You just use the formula, Wallis formula. Both the powers are even, so it will be ultimately, you see, for this integration, the limits are 0 to pi by 2. So you can use Wallis formula. It will be 7 by 8, then 5 by 6, then 3 by 4 half. When it is half, it will be ended by pi by 2. For this, it will be 9 by 10, 7 by 8, 5 by 6, 3 by 4 half. When it is ending by half, the last factor will be pi by 2. Now you do this algebra, you are getting this result. One more integration, 0 to pi x cos to the power 4x dx. Here you cannot use the Wallis formula directly because the limits are not 0 to pi by 2. And also along with this cos to the power 4x, we have a factor x. But we can remove this x. How? Let us use this property. It was property number 4. I told you in the beginning that this property is very, very important. Integral 0 to a fx dx equal to integral 0 to a f of a minus x dx. So first you use this property here. So in the whole of this function, you just replace x by a minus x, and your a is pi. So integration 0 to pi, we are naming it by I. Integration 0 to pi x cos to the power 4x dx will be integration 0 to pi minus x into cos of pi minus x whole to the power 4. And cos of pi minus x, actually it is minus cos x, but the power is even. So ultimately the sign will be plus. So you have pi minus x into cos to the power 4x dx. Now you separate two terms. The first term will be pi into integration 0 to pi cos to the power 4x dx, and the second term will be integration 0 to pi x into cos to the power 4x, which is exactly the same thing from which we started. It is nothing but I. So we can take it to the left side. So in the left side, you will have now 2i, and in the right side this. Now let us write this pi as 2 into pi by 2. Now we will use this property. You see, it was in property number 6, or yes, it was in property number 6. Let us go back. Which property? Yes. Oh no, I think this one, the 7, property number 7. 0 to 2a fx dx equal to 2 into 0 to a fx dx if f of 2a minus x equal to fx, and it will be 0 if f of 2a minus x equal to minus of fx. So let us check it, whether this function satisfies this property, this condition. Okay, so here 2 into pi by 2, we are writing pi as 2 into pi by 2. So in place of a, you have pi by 2. So at first you check this. What is your 2a? Your 2a is pi. Your 2a is pi. So if you take a cos to the power 4x as fx, we see that f of pi minus x equal to cos of pi minus x whole to the power 4. Cos of pi minus x is minus cos x, but because of this power, even power 4, ultimately it will be cos to the power 4x, and which is nothing but fx. So you see it satisfies this condition. F of 2 minus x, in place of 2a, you have pi. So f of 2a minus x equal to fx. So you can write it 2i equal to 2 into pi into 0 to pi by 2 cos to the power 4x. Then you apply Wallis formula and get the result. Now another math here, it is integration 0 to 2 pi sine to the power 4 x by 2 cos to the power 5 x by 2 dx. So at first we can write it like this, 2 into 0 to pi. Why? Because it also satisfies the same property number 7. Here f of 2 pi minus x. You see the upper limit is 2 pi. So this is your 2a. F of 2a minus x equal to, you just put in place of x, I'm sorry, I think there is a mistake here. Okay, in place of y x by 2, it should be in place of x, we have to put 2 pi minus x. Am I right? In place of x, we have to put 2 pi minus x. So ultimately it should be 2 pi minus x divided by 2. So ultimately it should be pi minus x, not 2 pi minus x. So this is a mistake here. It should be pi minus x. Sine of pi minus x by 2 whole to the power 4. This will be also cos of pi minus x by 2 whole to the power 5. So ultimately what is coming up? There should be a minus n and ultimately it should be 0. Yes, ultimately the result should be 0. So this is a mistake here. You please make it correct. Are you following me?
Yes, ma'am.
So what is the mistake here? Please tell me.
Ma'am, it should be pi minus.
Pi minus, actually x should be replaced. This is the limit for x, not for x by 2. So we have to replace x by 2 pi minus x. So when you write in place of x 2 pi minus x, it will be ultimately 2 pi minus x, the whole thing divided by 2. So ultimately it should be pi minus x by 2. So in place of 2 pi, it should be 2 here. Sorry, it should be pi here. So it should be sine of pi minus x by 2 whole to the power 4. And here it should be cos of pi minus x by 2 whole to the power 5. And this cos of pi minus x by 2 gives you minus cos x by 2. And this, because of this power 5, there should be a minus sign. And according to the property number 7, the result should be 0. So this is wrong. This is totally wrong. So please do it by yourself again. Okay, this first math, please do it by yourself again. Now I am doing this math, integration 0 to pi x sine to the power 5x cos to the power 6x dx. So at first you apply property number 4. You can write pi minus x in place of x. So it should be 0 to pi, then pi minus x into sine of pi minus x whole to the power 5 into cos of pi minus x whole to the power 6. So ultimately it becomes pi minus x into sine of pi minus 6 is sine x. So sine to the power 5x and cos of pi minus x is minus cos x, but because of this even power 6, ultimately the minus sign will be plus. So here you are getting the same function sine to the power 5x cos to the power 6x, but here pi minus x multiplied with this. So we separate the function, the two integrals. The first integral will be pi into integration 0 to pi sine to the power 5x cos to the power 6x, and here minus integral 0 to pi x into sine to the power 5x cos to the power 6x dx. Now this is the integral, the same integral from which we started. So let us take it to the left side, and in the left side you will have 2I, and in the right side pi into integration 0 to pi. Now let us check the property number 7. Property number 7, 2 into a. Your a is pi by 2 and 2a is pi. So f of pi minus x will be equal to sine of pi minus x whole to the power 5 into cos of pi minus x whole to the power 6. And ultimately you will get the same function fx. So this integral can be written pi into 2 into integration 0 to pi by 2 sine to the power 5x cos to the power 6x. Now you can write this cos to the power 6x. I have cancelled this part. We will go to the next page. Cos to the power 6x means cos square x whole cube. Cos square x whole cube. And cos square x means 1 minus sine square x. Then find the whole cube. A cube minus 3a square b plus 3ab square minus b cube. So then you do this multiplication and you will get how many integrals? There will be 4 integrals with limit 0 to pi by 2. The first one sine to the power 5x. The second one 3 into sine to the power 7x. The third one 3 into sine to the power 9x. And the fourth one sine to the power 11x. And then for all of these integrals, you can use Wallis formula. Wallis formula, there are the number of terms there. You have to do the algebra, and finally, this is your result. this much, okay, but here it is different because the upper limit is pi by 4. Upper limit is pi by 4. So what is happening here? Let us suppose that fx equal to sine to the power x 6x into cos to the power 6x. At first you check it. What comes if you write pi by 2 minus x in place of x? So f of pi by 2 minus x becomes sine of pi by 2 minus x whole to the power 6 into cos of pi by 2 minus x whole to the power 6. This gives you, this factor gives you cos to the power 6x, and this factor gives you sine to the power 6x, and which is actually equal to fx. Actually fx. So here, since this property is satisfied according to the property number 7, yes, according to the property number 7, you can write integral 0 to pi by 2 fx dx as 2 into integral 0 to pi by 4 fx dx, because this property is satisfied. So integral 0 to pi by 4 fx dx will be half of integral 0 to pi by 2 fx dx. Now, so integral 0 to pi by 4 will be equal to half of integral 0 to pi by 2. Okay. Now, we write any one of these two. Suppose we write this cos to the power 6s x to 1 minus, sorry, cos square x whole cube. So in place of cos square x, you are writing 1 minus sine square x. Again, this is a power to a minus b whole cube. Use the formula for a minus b whole cube, and these are the integrals coming for you. All of them with limit 0 to pi by 2. The first one with sine to the power 6x, second one sine to the power 8x, the third one sine to the power 10x, and the fourth one sine to the power 12x. So easily you can use Wallis formula, but there will be a number of terms and the algebra should be done by you. After doing this algebra, this is your result, 5 pi by 4096. Now this math, I equal to 0 to pi by 2 sine square x dx divided by sine x plus cos x. At first you use the property number 4. I told you this is very, very important. In place of x, you can write pi by 2 minus x. So the limit does not change, 0 to pi by 2. So the upper term will be sine of pi by 2 minus x whole square. In the lower term, it will be sine of pi by 2 minus x plus cos of pi by 2 minus x. The upper part becomes cos of x whole square. That means cos square x. And in the lower term, cos x plus sine x, because both the angles are in the first quadrant. Now you see we started from this I equals to 0 to pi by 2 sine square x dx by sine x plus cos x, and here you are getting the same limit 0 to pi by 2, but here the upper part is cos square x, but the lower part is same. So if you add these two integrals, you can write it 2i. 2i will be sum of these two integrals, and in the upper part you are getting sine square x plus cos square x, which gives you 1. So ultimately this 2i becomes 0 to pi by 2 dx by cos x plus sine x, and we have already evaluated this type of integration. We have to use the formula involving tan. Cos x means 1 minus tan square x by 2 divided by 1 plus tan square x by 2, and sine x means 2 tan x by 2 divided by 1 plus tan square x by 2. So now you do the algebra. 1 plus tan square x by 2 means sec square x by 2. It can be taken to the upper side, and at the lower side do this LCM and do the sum. Ultimately you are getting this. So now you try to write a whole square involving this tan x by 2. So you rearranging the terms, you can write it like this: 2 minus 1 minus tan x by 2 whole square, and then you let us take a substitution. Suppose 1 minus tan x by 2 equal to u. So which gives you minus half sec square x by 2 dx equal to du. So sec square x by 2 dx will be minus 2u du. And the limits will be changed. When x equal to 0, u will be 1. And when x equal to pi by 2, that means 10 pi by 4, 10 pi by 4 is 1, so the value of u will be 1. So the limit will be 1 up to 0. 1 up to 0. In the upper part, you are getting minus 2 du. Minus 2 is taken outside, and in the lower side, 2 minus u square. Adjust the minus sign with the limit, so it will be... Okay, here I didn't adjust the minus sign, it is already there, and use the formula for what? Dx by a square minus x square, dx by a square minus x square. It gives you 1 by 2a into ln of a plus x divided by a minus x. So root 2 in the ln of root 2, because a square is 2, so a will be root 2. So in the upper part, it will be root 2 plus u divided by root 2 minus u, and then use the limits. Ultimately, this is your result. Shall I do one more? Shall I do one more? Actually, our time is over, isn't it?
Yes, miss.
Yes, ma'am.
So shall I end our close here, or do you have class now? If you do not have any class now, we can proceed, because we missed almost 30 minutes. Shall I proceed? Do you have any class, any one of you? Please answer me. Do you have any class at this moment?
No, miss.
No. So if it is a no, let me proceed. Let me do, because we missed almost 30 minutes. We missed. So let us do math. This math, it is very important. I equal to integration 0 to pi by 4 ln of 1 plus tan theta d theta. This is a very important integral. So at first we use that same property number 4. Your a is pi by 4, and this theta can be replaced by pi by 4 minus theta. So this will be, this I will be equal to integral 0 to pi by 2 ln of, use a third bracket, then 1 plus tan of pi by 4 minus theta. And let us now use the formula for trigonometric formula for tan of a minus b. What is the formula for tan of a minus b? It is tan a minus tan b divided by 1 plus tan a into tan b. So if you use this formula, it will be ln of 1 plus tan pi by 4 minus tan theta divided by 1 plus tan pi by 4 into tan theta. And tan pi by 4 is 1. So it will be 1 plus 1 minus tan theta divided by 1 plus tan theta. Then do this addition. Your LCM will be 1 plus tan theta. Here comes 1 plus tan theta, and then 1 minus tan theta. So tan theta cancel out. It is 2 by 1 plus tan theta. Ln of 2 by 1 plus tan theta. Now you separate, use the property of logarithmic function. Ln of x by y equals to ln x minus ln y. So it will be ln of 2 minus integration ln of 1 plus tan theta. And it is the same thing from which we started. Integration 0 to pi by 4 ln of 1 plus tan theta, and we are getting the same thing. So you can, this is nothing but I, so let us take it to the left side. So 2I equal to pi by 4 ln 2. So the value of I will be pi by 8 into ln of 2. So you see how easily the result is coming, just using the property of definite integral. I means this, 0 to pi by 2 ln of 1 plus tan theta. The value is pi by 8 ln of 2. Now another integration, 0 to pi by 2 in the upper part sin square x dx divided by 1 plus sin x cos x. Here again we will use that property number 4. So you write pi by 2 minus x in place of x. So here comes sine of pi by 2 minus x whole square. In the lower part, 1 plus sine of pi by 2 minus x into cos of pi by 2 minus x. In the upper part, you are getting cos x whole square. That means cos square x, and in the lower part 1 plus cos x sin x. So exactly the same function, but the upper part is different. Here in the starting it was sin square x, now it is cos square x. So if you add these two, in the left side you will get 2i, because both of them are equal to I. So 2i will be equal to sum of these two, and when you add this, the LCM is same, 1 plus sin x cos x, in the upper part sin square x plus cos square x, which means 1. So in the upper part we have simply dx. So you have now 2i equal to integration 0 to pi by 2 dx divided by 1 plus sin x cos x. Now let us write for this one, we write sin square x plus cos square x. And then you divide upper part and lower part by cos square x. So in the upper part it will be sec square x. In the lower part this term will be tan square x, then plus 1, then plus tan x. Sin x by cos x, tan x. Okay, now let us take a substitution tan x equal to u, which gives you sec square x equal to du, and you change the limit. When x equal to 0, u will be 0. When x equal to pi by 2, when x equal to pi by 2, u will be infinity. So here you are getting 0 to infinity. 0 to infinity, sec square x dx is du, and in the lower part it will be u square plus 1 plus u. Now let us try to get a perfect square from the lower part. You can write it like this: u plus half whole square plus 1. This was the extra term. 1 over 4 was the extra term. So 1 minus 1 by 4, which gives you 3 by 4. So u plus half whole square. And you can use a substitution, but without using a substitution, you can perform this integration. It is actually of the form x square plus a square. And the formula is 1 over a tan inverse x by a. In place of x, you have u plus half. The coefficient of u is 1. So if you take a substitution, u plus half equal to z, you will get a du equal to dz. So same thing. We don't need any substitution here. It will be 1 by a. That means 1 over root 3 by 2. Yes, 1 over root 3 by 2. Then tan inverse, your x is u plus half and a is root 3 by 2, and limit is 0 to infinity. So 2 by 3 into tan inverse. When you put infinity, use infinity in place of u, the whole thing becomes infinity, and tan inverse infinity means pi by 2. And here what is coming up when you put u equal to 0, it will be 1 by root 3, and tan inverse 1 by root 3 means the angle 30 degree. 30 degree angle means pi by 6 in radians. So after doing this algebra, you are getting this result. 2I equals to 2 pi by 3 into root 3. So I will be equal to pi divided by 3 into root 3. Now this math show that integration 0 to pi by 2 ln of sin x dx equal to integration 0 to pi by 2 ln of cos x dx. Both the integrals are same, and the result is pi by 2 ln of half. So at first, use the property number 4. Write pi by 2 minus x in place of x. So this integral, which is named as I equal to 0 to pi by 2 ln of sin x dx, will be equal to integration 0 to pi by 2 ln of sine of pi by 2 minus x. And sine of pi by 2 minus x gives you cos x. So you are getting this equality. This integration is exactly equal to 0 to pi by 2 ln of cos x dx. So now both the integrals are equal to I. So if you add them, you will, in the left side you will get 2I, and in the right side integration 0 to pi by 2 ln of sin x plus ln of cos x. So ln of a plus ln of b. If the bases are same, it will be ln of a into b. So you are getting here ln of sin x into cos x. This is your argument of ln. And sin x cos x means sin 2x divided by 2. Now you can separate the two terms like this: ln of sin 2x dx minus integral ln of 2 dx. And here for this 2x, let us take a substitution. Suppose that 2x equal to pi minus z. So take the differential, it will be 2 dx equal to minus dz. So dx will be minus dz by 2. Now adjust the limits. When x equal to 0, z will be pi. And when x equal to pi by 2, you are getting pi here, so z will be equal to 0. So the limit will be now pi to 0. The limit will be now pi to 0, and for the first integral, pi to 0, it will be ln of sine of pi minus z. Yes, ln of sine of pi minus z. Then minus, if you perform this integration, ln of 2 is a constant, so ln of 2 into integration 0 to pi by 2 dx, which gives you pi by 2. So ultimately the result is minus pi by 2 ln 2, which is coming from the second term, and this is from the first term. Now you adjust the minus and with the limits. So the 0 will be the lower limit, the upper limit will be pi, and this minus sign will be plus. So again, you know, sine of pi minus z is nothing but sine z. So it becomes ln of sine z dz. And you can, without changing the limits, you can change the variable. It comes from the first property. So it becomes 0 to pi ln of sine x dx. What was the starting? In the starting, the limit was pi by 2, but the function was same, ln of sin x. And here we are getting 0 to pi 0 to pi ln of sine x dx. Okay, so let us write it like this: 0 to 2 into pi by 2. So your a is pi by 2. Now let us check it. Ln of 2 into pi by 2 minus x equal to ln of sine of pi minus x, which is equal to ln x. So it satisfies the property f of 2a minus x equal to f of x. So you can write it half, the half was there, and this integral can be written as 2 into integral 0 to pi by 2 ln of sine x dx. And this integral has already been evaluated. Oh no, I'm sorry. It is nothing but I from which we started. So this is I. In the left side we had 2I, yes. In the left side we have 2I, and in the right side you are getting these two to cancel out, I minus this. So you take this I to the left side and 2I minus I gives you I. So I equals to minus pi by 2 ln of 2, which gives you pi by 2 ln of half. So this is your answer. Without evaluating the definite integral directly, we have just used the properties of definite integrals and we are easily getting the result. Now next math, integration 0 to 1 ln of 1 plus x divided by 1 plus x squared dx. This is also another important integration. Let us use a substitution here. Suppose that x equal to tan theta. So dx will be equal to sec squared theta d theta. So here it becomes 1 ln of 1 plus tan theta divided by 1 plus tan squared theta means sec squared theta. This sec squared theta d theta. So this sec square cancel out and you are getting 0 to pi by 4 ln of 1 plus tan theta d theta. We have evaluated this integral before. Was it with the same limit? Yes. Integral 0 to pi by 4 ln of 1 plus tan theta d theta. The method we applied here to get the result, we will do the same thing for this integral. Once you get this, you see, I have shown it here again. Integral is same. And we have evaluated in this way. Use the property number 4, write pi by 4 minus theta in place of theta, and use the formula for tan of a minus b. Then do the algebra, do this addition. It will be ln of 2 minus integral ln of 1 plus tan theta. And this is the same thing from which we started, so 2i. So ultimately the result is I will be equal to pi by 8 ln of 2. So you see, without evaluating the integral using our usual method, just using the property, how easily we are getting the result. The next math, integration 0 to pi ln of 1 plus cos x. Ln of 1 plus cos x, name it I. So again use the property number 4. So write pi minus x in place of x. So it will be ln of, use a second bracket here, 1 plus cos of pi minus x. And cos of pi minus x means minus cos x. So this I equals to 0 to pi ln of 1 plus cos x dx. And this is also equal to, okay, it is not 1, I'm sorry, it is pi. In place of 1, it should be pi. Please make it correct. 0 to pi ln of 1 minus cos x dx. So if you add these two, you will get in the left side I, because both the integrals are equal to I. So in the left side, you are getting 2I. In the right side, integration 0 to pi ln of 1 plus cos x plus ln of 1 minus cos x. So ln of a plus ln of b gives you ln of a into b. So it will be ln of 1 minus cos square x, and 1 minus cos square x means sine square x. And you can take these two outside. So it becomes 2 into integration 0 to pi ln of sine x. Now use this property. Since sine of pi minus x equal to sine x, it satisfies the property f of 2a minus x equal to f of x, property number 7. So using the property number 7, you can write it like this. It will be, if you write except this 2, let us consider this integral as I. So I equal to integral 0 to 2 into pi by 2. So since this property is satisfied, you can write it like this. It will be equal to 2 into 0 to pi by 2 ln of sine x dx. And we have already evaluated it. But here you have to show it. here you have to show it. This was the calculation that we have done to evaluate this integral 0 to pi by 2 ln of sin x. At first we use the property number 4 to get ln of cos x, and then we added, then use the property of trigonometric function. Sin x cos x means sin 2x by 2. So then separate ln of sin 2x minus ln of 2. Okay, and then okay, exactly the same thing that we have done here, in this math to evaluate this integral. What we did here to evaluate this integral 0 to pi by 2 ln of sin x dx, each step should be shown in your calculation. These whole steps should be shown in your calculation for evaluating this integral here. Okay, once you get this, you have to show your calculation, and finally the result of this part was pi by 2 ln of half, and there was a 2 here outside, so 2 into pi by 2 ln half, part 2 to cancel out, so pi ln of half. This is the result. Next math, integration 0 to 1 cot inverse 1 minus x plus x square. Here we have used a property of inverse circular function. Tan inverse x is cot inverse 1 by x, and cot inverse x is tan inverse 1 by x. So this cot inverse whole thing can be written as tan inverse 1 by this. Consider this whole thing as x. So cot inverse x equal to tan inverse 1 by x. So tan inverse 1 by 1 minus x plus x square. Now let us write the upper part. This 1 can be written in this way, x plus within bracket 1 minus x. This x and minus x cancel out. Ultimately we are left with this 1 only. So tan inverse x plus 1 minus x divided by, from the lower part you can write it like this, 1 minus, take minus x common, so minus x into, it will be 1 minus x. So now let us use the property of this inverse circular function, tan inverse a plus tan inverse b. You know the formula, it is equal to tan inverse a plus b divided by 1 minus a into b. Tan inverse a plus b divided 1 minus ab. So here if you consider this x as a and 1 minus x as b, so a plus b divided by 1 minus a into b, and this is tan inverse. So tan inverse a plus b divided by 1 minus ab, so it will be nothing but tan inverse a plus tan inverse b. That means tan inverse x plus tan inverse 1 minus x. So up to this step we have used property of inverse circular function. Okay, now you separate these two integrals. Integral 0 to 1 tan inverse x dx, and here integral 0 to 1 tan inverse 1 minus x. Now here in the second integral, let us use the property number 4 for the definite integrals. So in place of x, let us write 1 minus x. So it will be tan inverse 1 minus within bracket 1 minus x. And when you remove this first bracket, 1 and minus 1 will cancel out and you will get minus minus plus x. So tan inverse x. And these two are the same thing. So it will be 2 into integration 0 to 1 tan inverse x dx. Now you just apply the method of integration by parts. First function is tan inverse x and the second function is 1. So the first function into integration of second function. So x into tan inverse x, limit 0 to 1 minus d dx of first function. So whole integration 0 to 1, it will be 1 by 1 plus x square, and integration of dx will be x. So x by 1 plus x square. Now here let us write it like this. What is the derivative of the lower part? It is 2x. So let us write it here 2x, and okay, there is a 2 here. So you just multiply by these two. So 2 into x, okay, use the limits. So 2 into 1 into tan inverse 1. Tan inverse 1 means pi by 4, and tan inverse 0 is 0. So the lower limit will give you 0. So using the upper limit, you will get 2 into tan inverse 1. That means 2 into pi by 4. And these two multiplied these two with this x. So 0 to 1, 2x dx by 1 plus x square. You can take 1 plus x square as u. So du will be equal to 2x dx. So 2x dx, you can replace it by du. So du by u. du by u, integration of du by u means ln of u. That means ultimately ln of 1 plus x square, because u is 1 plus x square. Then use the limits. So ln of 1 plus 1 means ln of 2, and ln of 1 plus 0, that means ln of 1, which is 0. So ultimately pi by 2 minus ln of 2. Now this integration 0 to pi x dx divided by a square cos square x plus b square sin square x. So again we use that particular property number 4. Replace x by pi minus x. So in the upper part pi minus x dx, and in the lower part you are getting a square cos of pi minus x whole square, that means cos square x. Same thing, b square into sine of pi minus x whole square, that means sin square x. So you are getting exactly the same thing, pi minus x dx divided by a square cos square x plus b square sin square x. Then you separate the two terms. The first term will be containing pi, so pi into integral 0 to pi dx divided by this, then minus integral 0 to pi x dx divided by this, which is nothing but I from which we started. So let us take this term to the left side. So 2I should be equal to pi into this, pi into this. Now let us see whether this function satisfies the property f of 2a minus x equal to f of x. Yes, here 2a is pi, so cos of pi minus x whole square equal to cos square x, which is fx, and cos of sine of pi minus x whole square is also sine square x. So these functions, both of them, the whole of this is satisfying the property involving in property number 7, f of 2a minus x equal to f of x. So this integral can be written as 2 into pi into z integral 0 to pi by 2 dx by a square cos square x plus b square sin square x. Okay, now here we are using a technique. If you do not know this technique, the integral will be very complicated to be evaluated. So here, let us take this cos square x common. Take this cos square x common, it will be cos square x into a square plus b square into tan square x. Now suppose that tan x equal to u. Tan x equal to u, so sec square x dx will be du. And 1 by cos square x. 1 by cos square x means sec square. So sec square dx goes in the upper part, and in the lower part you have a square plus b square u square. Yes, a square by b square plus u square, because tan square is taken will be u square, and again you take b square common. So in the first term you will have a square by b square. We are taking b square common. So in the outside, okay, in the left side we had a 2, these 2 and these 2 cancel. So I will be equal to pi divided by b square into integration. Okay, now adjust the limits. When x equal to 0, tan 0, 0. So lower limit is 0. When x equal to pi by 2, tan pi by 2 is infinity. So upper limit for u will be infinity. So pi by b square integration 0 to infinity. The upper part gives you just du, and the lower part a square by b square plus u square. So you can here use the formula for tan inverse x by a. Dx divided by x square plus a square, it is nothing but 1 over a tan inverse x by a. Your a is root over this, that means a by b. So 1 by a by b into tan inverse u divided by a by b. Then you use the limits. When u is infinity, the whole thing becomes infinity. Tan inverse infinity means pi by 2. And when you put u equal to 0, the whole thing becomes 0, and tan inverse 0 is 0. So ultimately it will be pi square. Yes, there will be 2 pi square divided by why this 2 is coming? Okay, I'm sorry, tan inverse infinity is pi by 2. So there will be a 2ab in the lower side, pi square divided by 2ab. Now this integration, we have to use the same property number 4 again. Write pi minus x in place of x. Write pi minus x in place of x. In the lower part you are getting exactly the same function, and in the upper part pi minus x. Then you separate the two terms. In the first term there will be a pi integration 0 to pi dx by this, there is a whole square. You say what is the difference in between the previous one and this one? In the previous one there was no whole square, but everything is same, but in our current math there is a whole square. A square cos square x plus b square sin square x whole square. Okay, and this is the same thing I, so let us take it to the left side. So 2I will be equal to pi into this. Now what we are doing, we are taking here cos square x common. There is a whole square, so it will be cos to the power 4x. Cos to the power 4x into b square plus s square tan square x, then whole square. And 1 over cos to the power 4x means sec to the power 4x dx. And again here we are taking a substitution. Suppose that a tan x equal to b tan theta. So this is, if you do not know this technique, it will be very, very complicated. The previous one actually was not so complicated, but this one is complicated. If you use this substitution, the calculation will be very easy for us. Suppose that a tan x equal to b tan theta, then take the differential a sec square x dx will be b sec square theta d theta. Now adjust the limits. When x equal to 0, tan 0 is 0, so theta will be 0. When x equal to pi, then theta should be pi, right? When x equal to pi, theta should be pi. Because a tan x equal to b tan theta, right? When x equal to pi, theta will be pi. Okay, so now integration 0 to pi sec to the power 4x dx. Okay, let us write this sec to the power 4x as sec square x into sec square x, and 1 sec square x can be written as 1 plus tan square x. And this sec square x dx can be replaced by b by a. Sec square x dx is b by a sec square theta d theta, right? And here 1 plus, it will be b square by a square tan square theta. Yes, b square by a square tan square theta. And in the lower part, b square plus a square into, okay, a tan x equal to b tan theta, so it will be b square tan square theta. In the next step, let us take b square common from the lower part, and in the upper part we have a b, so ultimately in the lower part there will be b cube, and take this a square a cube common, so here comes a square plus b square tan square theta into sec square theta d theta, and another a cube goes down, right? Another a cube goes down. Now 1 sec square theta is cancelling out. So in the upper part you have a square plus b square tan square theta, in the lower part a cube b cube. So take this a cube b cube outside, pi by a cube b cube, and here a square plus b square tan square theta divided by sec square theta d theta. Now safely you separate the two terms. A square by sec square theta means a square cos square theta, and here b square tan square theta by sec square theta, it means b square sin square theta by cos square theta into cos square theta. So cos square cancel out, a square cos square theta plus b square sin square theta. And now you use the trigonometric formula, take a square outside, separate the two integrals, and then take a square outside, take b square outside, and use the trigonometric formula. 2 cos square theta equal to 1 plus, oh no, without using the trigonometric formula, you can directly use the property and then Wallis formula. Because cos of pi minus theta whole square equal to cos square theta. So the property is satisfied here also. Sine of pi minus theta whole square equal to sine square theta. So f of 2a minus x equal to f of x. So it can be written as 2a square into 0 to pi by 2 cos square theta. This 2 is common here and here, so these two can be taken outside. 0 to pi by 2 cos square theta, it will be a square is there, half into pi by 2. Here b square into half into pi by 2 using Wallis formula, and this is your result. And this was the last math in this section. This was the properties of definite integrals, and we have completed this section. Thank you so much for for your perseverance. I will upload this file. Thank you so much for remaining with me. Okay, thank you so much. I'm leaving now. I'm leaving now. Thank you so much. Walaikum assalam. Walaikum assalam. Thank you again. Thank you again so much for remaining with me 30 minutes more. Thank you so much.